We will be discussing about a chapter in electrical engineering and electronics that is called as nodal analysis with sources. It is called as nodal analysis with sources. Nodal analysis with sources. So this is the heading that we are going to discuss today. So before getting into the entire part of the video, before getting into the lecture, first we'll analyze what is meant by node. Node is node, N-O-D-E, N-O-D-E, node. So node is a point in a circuit. Okay, it is a junction point. Node is a junction point where two or more elements are joined together. So that is called as a node. For example, let us consider a circuit like this. We have a resistor like this. I have another resistor like this. I have another resistor like this. Okay, it might be these are called as elements. These are called as elements. Stands for E. Okay, so element can be anything like a resistor, or it can be a capacitor, it can be an inductor. Anything that is being added to the circuit is called as a element. Okay, so now in this resistive network, this is a network. So in this resistive network, if you want to know what is a node, if you want to pinpoint or locate a node, this will be a node. Why I am terming it as a node? Because this node is a junction point, number one, and number two is this junction point should be formed in such a way that it should connect elements. It should connect elements with two or more elements. It should be connected with two or more elements. So that if it is so, then this is called as node. I will call this as node A. This will be node A because here this is one element, this is two and a second element, and this is the third element. So as far as a node definition is concerned, a node is a junction point in a circuit where two or more elements are connected together. So that point, that junction point is termed as node. Now we are going to see the nodal analysis. We are going to analyze the nodes. We are going to analyze the nodes that is being involved in an electrical network. So this is all about the node. Okay, this is the definition of a node. So this node is mainly used in case this nodal analysis, this method is mainly used in cases where there are more number of parallel circuits, and this parallel circuits may, and these circuit is mainly used in electronic circuits. This method is mainly used in electronic circuits where there are a lot of parallel circuits are being involved into it. So we are using this nodal analysis especially in electronic circuits where the entire circuit is being grounded. Okay, so here you have, in this nodal analysis you have nodes, and you have one specific node which is exceptional, which is called as a reference node. This is called as a reference node, or we call it as a datum node. We call it as a datum node. Okay, this reference node or datum node will be grounded. Okay, it will be connected to the ground. So why it is being connected to the ground means for safety reasons. So in case if there is any high voltage, high shocks, electric current is passing, it will be moved to the earth, the ground terminal. So only we are using this reference node or datum node, which is nothing but the ground terminal. Okay, so we have nodes, we have this reference or datum node. Okay, so the formula that is used in this is n minus 1. N minus 1 is a formula which we are using in this nodal analysis to find the number of equations. For example, if you are having an electrical circuit like this, so you have a lot of networks, intermediate and independent networks will be there like this. So if you want to find how many equations, if you want to solve this electrical network, a very complicated network means, if you want to solve this network, you need to know how many equations you need to perform. You need to form. At the end up so you want to find how many equations are being involved into it. So that can be identified, that can be found by using the formula n minus 1, where n stands for the number of nodes. Number of nodes. Number of nodes means here nodes plus this reference node is also will be added to it. A reference node is also added to it. So this is the formula. This formula is used to find the number of, now this is number, n stands for number of nodes. So n minus 1, this formula says that how many equations can be framed in this circuit. In this circuit to find the voltage, to find the value of current, or to find the value of resistance. So n minus 1 is the formula. N is nothing but the number of nodes. In this number of nodes, a reference node is also included into it. Okay, so now we'll get into the circuit analysis, that is a node analysis with sources. Okay, this is the name for the name of the derivation which we are going to derive today. So I'll draw the circuit diagram first. Okay, so you'll be getting an idea about what this nodal analysis is all about. So here I am taking three resistors. I am taking three resistors in series. Okay, so I'm naming this resistor as R1, this as R2, and this resistor as R3. Now I am forming a junction at this point, and I am connecting another resistor. Again I am taking another point here and I am connecting a resistor. Now I am combining these two branches, two resistive branches I am combining here, and I am forming a junction at this point, and I am making this point to be grounded. Okay, this point is being grounded. So this is called as reference node or datum node, because reference or datum node is a node which is grounded, which is connected to the ground terminal of the electrical circuit. So now here I am adding a battery source. I am adding a battery source which I am naming it as E1, and I am connecting this negative terminal of the battery to the node, reference node. Again I am connecting another battery source, and I am connecting this negative terminal of the second battery, which has an EMF of E2 to the negative E2 to the datum node. So this is R1, this is R2, this is R3 are resistors, and this will be R3, this will be R4, this one will be R5. Right? So this is the setup. So now this point is considered to be node. Okay, let us assume that this point is point number 1, and this is point number 2, junction number 1, junction number 2. For junction 1, junction 2 only, I am naming it as point 1 and point 2. Okay, so this is junction 1, junction 2. Okay, so these 1 and 2 is nothing but they are called as nodes, because nodes means here, if you take, means a node is a junction point. As per the definition of a node is a junction point where it is connected with two or more elements. So here in this node, this node is being connected with three elements, 1 2 3. Okay, here in this node is also connected with three elements, 1 2 3. So obviously these 2 points, these 2 junction points are considered to be nodes in this electrical circuit. This is called as the reference point or the datum point. So so you have one, two, three. You have totally three. So I'll mark it as a datum. Datum. So you have three nodes. You have three nodes. So you want to know how many equations you need to form. So for that you need to use this formula n minus 1. Okay. So n is the number of nodes. Number of nodes is 3. 3 minus 1, which is equal to 2. Therefore 2 is the two equations you need to form. So two equations that we need to form in order to solve this network. So you are using this formula n minus 1. So n stands for the number of nodes that is involved in this electrical network. So fine. Now we will start working with the circuit. So we will name the direction of currents before starting with the circuit. So you have this battery E1. When it is connected, you have a current that is flowing through R1. Let us assume that the current is I1. I1 be the current that is flowing from the positive terminal of E1 and it flows through the resistor R1. Here let us assume a current I4 happen to flow through the resistor R4. This is I4. Again, let us assume another current I2. When this current I1 reaches the point junction 1, which is called as the nodal point, this point the current divides into two it divides into two values and each current flows through individual branches. So I1 is being divided into I4 and I2. Let us assume that I2 is a current which flows through the resistor R2. Similarly, here from this battery terminal, the second battery terminal is E2. Here from the positive terminal of this battery, a current I3 flows through the resistor R3. A current I3 flows through the resistor R3, and also let us assume that a current I5 flows through the resistor R5. So we have marked the direction of the current in this resistive network. Okay, so I1 is a current which flows from the battery E1. I1 at the point A bifurcates into two current, I2 and I4. I2 passes through the resistor R2 and I4 passes through the resistor R4. And at the point 2, you and at the point 2, 2 is also a node. Here a current I3 gets inside the node and a current I4 goes outside the node. This current I3 is being supplied by the battery terminal E2 such that the positive terminal of the battery E2 is connected to the resistor network, resistor R3. So here this is the datum. So now what we need to do is, let us assume that this point is VA. This is VA and this point is VB. What is VA and VB means? Let A and B be the point at where the node is located. Let A be a point where this node is located and B be a point where this second node is located. So the voltage that is being developed in that point A and point B is marked as VA and VB. So VA is the voltage at point node A, VB is the voltage at node B. So VA, VB we have marked in the circuit diagram. So first thing is, I am going to consider this node 1. That is node, let us assume this node 1. This is node 1. So in this node 1, what I am going to do is, in this nodal analysis, I will be using only Kirchhoff's KCL, not KVL. I will be using only the current law, not the voltage law. So in this nodal analysis, if I use the current law at this point, at this node, I will be getting node 1, apply KCL. If I apply KCL, here it will become the current which is entering the junction will be considered to be positive, and the current which is moving out of the junction is considered to be negative as per the current law, and this equation will be equated to 0. Okay, so applying KCL at the point at node A. So node 1 or node A, it will become I1, because I1 is positive because it is entering into the node. I1 minus I2 minus I4 equal to 0. I1 minus I2 minus I4 equal to 0. So now I have framed an equation and I need the value of these individual currents. So I want to find the value of I1, find the value of I2 and find the value of I4. Let us assume that this is equation number 1. So I want to find the value of I1. So I1 equal to, so what is I1? I1 equal to, by Ohm's law, I is nothing but the ratio between the voltage and resistance. I equal to V by R. So I1 is here. I1 is here. So the potential difference that is happening in between this point. So I1 is a current which is flowing from this point to this point. So the voltage that is being encountered here will be the difference between the EMF of the battery and the node voltage. So that is nothing but I1 is equal to E1 minus VA. E1 minus VA. I1 is equal to E1 minus VA divided by the resistance through which this current is flowing. So the resistor value is divided by R1. So this is the value of the current. I1 is equal to E1 minus VA divided by R1. Similarly, what is I2? We need to find the value of I2. I2 is a current which flows from this node A to node B. That is, from VA to VB, the current flows through the resistor R2. So if I want to find the value of I2 by Ohm's law, I2 is equal to the difference in this potential, the difference in voltage between the two nodes. So in this node A, you will be having a voltage. Node B also you will be having another voltage, that is VA and VB. The difference between the two voltages will be taken into account, will be taken into consideration. So I2 is equal to VA minus VB, which is VA minus VB divided by the resistor through which this current I2 is moving. So the I2 moves through the resistor R2, that will be divided by R2. So the value of I2 is VA minus VB divided by R2. Now VA minus VB divided by R2. Now we need to find the value of I4. So what is the value of I4? I4 is a current which is passing through the resistor R4. So if you want to find the value of I4, I4 equal to, here the current is flowing from VA and it is passing through the resistor R4 and it is reaching the datum node. So you have VA, the only voltage which is there is VA, that is the node voltage at A, that is nothing but VA. So I4 is equal to VA divided by R4. I4 is equal to, this is VA divided by R4, VA divided by R4. So we have found I1, I2, I4. So these are the three parameters that we need to find in order to solve the equation. So I am substituting these values in this equation number 1. So I1 is E1 minus VA divided by R1. E1 minus VA divided by R1 minus I2 is VA minus VB divided by R2 minus I4 is minus VA divided by R4, which is equal to 0. I am equating all the parameters, the value of every parameter which I had found, that will be equated to 0. as per the current law. Current law states that the current, sum of the current which is entering into the junction is equal to sum of the current which is moving out of the junction. Sum of incoming current is equal to sum of outgoing current. So based on that, I am equating this to 0. So now this will become E1 divided by R1. E1 divided by R1 minus VA divided by R1. E1 divided by R1 minus VA divided by R1 minus VA divided by R2 minus into minus plus VB divided by R2 minus VA divided by R4 equal to 0. So here you have the node voltage at A, the node voltage at B, and the battery EMF is there. So what you need to do is that you need to club all the identical parameters. Okay, club all the identical parameters and solve the equation So what you need to do is you have minus VA minus VA minus VA here. So what you're going to do is minus here it will become minus VA, putting it under bracket 1 by R1 plus 1 by R2 plus 1 by R4 minus VA. When it is taken outside, I'll be getting 1 by R1 plus 1 by R2 plus 1 by R4 plus VB divided by R2 plus E1 by R1 plus E1 divided by R1, which is equal to 0. So VA, VB and plus E1 by R1 equal to 0. Now what I'm going to do is I'm going to change the signs. So if I change the sign, it will become VA into 1 divided by R1 plus 1 divided by R2 plus 1 divided by R4 minus VB by R2 minus E1 by R1 equal to 0. So this is the equation which we had formed. So I'm changing all the negative sign to positive sign and the positive sign to negative sign. So this is the final equation which I had obtained. So let it be equation number 2. Okay. So now next thing is we need to solve for node 2. So solving for node 2. Solving for node 2, that is we are going to find the voltage. We are going to solve for node 2. We are going to form the equation at the node. Node 2. Okay. So for forming node 2, what you need to do? Node 2. So now applying the current law at the junction point 2. So if I apply the current law at junction point 2, the sum of incoming current is considered to be positive and the sum of outgoing current is considered to be negative. So what are the incoming currents that is coming inside? The incoming currents are I2 plus I3 plus I3 minus I5 equal to 0. I2 plus I3 minus I5 equal to 0. So now we know the value of I2. I know the value of I2. The value of I2 has been already found. I2 equal to VA minus VB divided by R2. What is the value of I3? I3 is we need to find. The value of I3 will be, I3 is nothing but you have this I3 is a current which is flowing from the positive terminal of the battery E2 and it is passing through the resistor R3. So what I'm going to do is I3 is nothing but the difference between the potential from this E2 to VB. The difference between the potential. What is the difference between the potential is E2 minus VB divided by R3. R3. So this is the value of I3. I3 will be E2 minus VB divided by R3. So now what is I5? So we don't know the value of I5. I5 equal to, see, I5 is a current which is flowing from the point B through the resistor R5 and it reaches the datum node. So I5 can be written as VB divided by R5. That is VB divided by R5. Okay, this is the value of I5. That is VB divided by R5. So with the values which we had obtained, we need to substitute in this expression. So substituting in this expression, I2, the value of I2 is VA minus VB, VA minus VB divided by R2 plus I3 is E2 minus VB divided by R3 minus I5 is VB divided by R5 equal to 0. So I2 value is VA minus VB divided by R2 plus E2 minus VB divided by R3 minus VB by R5. I5 is VB divided by R5. So now what we are going to do is we need to split it up. So it will be VA divided by R2 minus VB divided by R2 plus E2 divided by R3 minus VB divided by R3 minus VB divided by R5 to 0. So now you have the voltage at the node A, the voltage at the node B and the EMF of the second battery. That is the second voltage source which we have connected in this circuit. So now it will become, we need to club all the VAs one side. Okay, so let us take all the VAs, all the VBs and all the E2. So we have only one VA, so VA divided by R2. Now how about VB? Put the minus sign here, minus of VB into 1 divided by R2 plus 1 divided by R3 plus 1 divided by R5. Okay, so this is VB. Now plus E2 divided by R3 equal to 0. E2 divided by R3 equal to 0. So this is the equation that we had formed. So this is equation 1, first equation. Actually this is equation is one equation. This is just for the identification I had marked it as 1. So in general practice, this is the equation which we had obtained. This is equation 1 and this is considered to be equation number 2. So in this we have two equations we had formed. We had formed two equations. Okay, in these two equations here we have three nodes, 1, 2, 3 nodes. So our formula is n minus 1. N minus 1 is a formula where we need to find the number of equations that has been involved in this, in the simplification of this circuit. Okay, so n minus 1, what is n? N is the number of nodes is 3 nodes we have including the datum node. So 3 minus 1 is nothing but 2. So 2 equations will be involved in solving this resistive network. So as per the formula we have obtained two equations. This is equation number 1 and this is equation number 2. Okay, so this is VA into 1 by R1, 1 by R2, 1 by R4 minus VB by R2 minus E1 by R1 equal to 0. This is equation 1 and this is equation number 2. So this is all about this nodal analysis. Here we have used two battery sources. Okay, so we have solved this, we have found the equations using two battery sources. So this is all about the derivation part. Okay. Thanks for watching this video. Please do subscribe my channel for more interesting and upcoming videos. Thank you.